Hi, this is Shaunak. I'm hereby sharing my generic library for microcontroller as Modbus RTU's claim, open to all. A couple of years back, I created a library that worked both on Cypress PSoC5 development kit and TI Stellaris Launchpad. As Arduino is a widely used platform for both education and industrial purpose, so I wanted to test this library successfully on Arduino Mega and Arduino Uno. When I began this work, I started with Arduino Mega and not Uno. The question is why? So the answer was a bit simple for me because of the complexity level and considering the volume of sensor integration and other communication peripherals, size of EEPROM, flash drive, everything is concerned. Arduino Mega is preferred because this is the Modbus RTU project. So whenever it is getting deployed, there are so many aspects come into picture. So that's why I preferred Arduino Mega, but it is not a mandatory thing. This can be tested on Arduino Uno as well. The choice is up to the developer. So let's look at the library. Once we get the understanding, we'll switch to on how to use this for the Arduino. There is a Modbus underscore RTU.h, there is a header file, and there is a Modbus underscore RTU.c, there is a C file. So this makes the library for this Modbus RTU slave. This section of defined constants is important to understand this functionality. But the first one is the Modbus slave address. You can set it from 1 to 247. Number of coils, I have taken 64. Making sure it has to be in the multiples of 8 if possible for you. Again, for the discrete inputs, it is 64. Make it sure to have it in multiples of 8. So every defined constant that you take here till this, you take it into consideration that it has to be the multiples of 8. That will be the easier part for the programming. The next section consists of declaration of arrays and functions. The C file consists of definitions. The important factor here is the checksum, the CRC checksum being calculated and checked. To get to know more about Modbus, I have a very good documentation from Modicon. I have also shared it in my blog. You can check it out later on. So this basically explains how queries are formed and responses are generated. So this will help to understand the library better. Here is the code for Arduino Mega that makes it a Modbus RTU slave. If you want to deploy this Modbus RTU generate library into any other microcontroller, you just need to take care of the EEPROM part, the UART part, and the timer part mentioned in this code. Try this code yourself. If you have any queries, any problems, any issues, just let us know. Soon we will be switching to the testing of this Arduino Mega code with qModbus, which is a Modbus Master Tool. Let's discuss the code for Arduino Mega that acts as Modbus RTU slave. This code, once understood theoretically completely, then the user or developer can use this code philosophy into any other microcontroller and get the things done with Modbus RTU slave. So let's go to the GitHub. This same code is available on GitHub of Modbus. There is a project called Arduino Modbus RTU Slave. Go to that. The qModbus tool that I mentioned is available here. It is used as a Modbus Master to communicate and test the Arduino Mega or any other microcontroller. The INO file here is the main code for Mega. So here are the defined constants, some variables and arrays. The EEPROM is initialized. These initialization values can be set by the programmer. So currently as that for coils and discrete inputs and holding guys, all these things are set some values. The read EEPROM function reads the EEPROM. It is only called once in the setup of the Arduino Mega. Update EEPROM whenever the new value gets updated, it gets stored in the EEPROM to retrieve on the power cycle. Timer is very key factor here. Timer is initialized with a method that it triggers for every 1 millisecond. And it can be enabled or disabled anytime the user wants it. USART is initialized. Here I have set baud rate as 9600. So the data sheet of ATmega 2560, or in the case of Arduino Uno, it can be ATmega 328P. That can be useful to set this function. There is a transmit function I have put. It just transmits a single character at a time. The timer, what it does is 2 consecutive set of data frames coming up from as a query from the Modbus Master has at least 4 millisecond delay in between. So when it exceeds its value of 4, it gets to know, the code gets to know that the data frame is received. So now it is going to process a data frame. It sets a flag. There is a flag which is being set. The setup function, again, it is like initializing the things. There is a status LED I put deliberately. It toggles on every query reception. So it is a very good tool to know that we are getting the correct query from the Modbus Master, including the checksum. Power of flag is being used here just for the initialization of the EEPROM. This if condition triggers only once, because once the EEPROM is set, the power flag value is bit different, so that it doesn't come again here. Then comes the read EEPROM. So EEPROM gets read every time the controller powers up, and it gets set values. USART is initialized, timer 0 is initialized with 1 millisecond, and it is disabled in the beginning. So you have to make a note of it. Interrupts are enabled. Upon the reception of Modbus data, the loop function starts checking that data and responses accordingly. So this entire loop functions behaves like that. And there is the last one, but not the least, is the USART interrupt, which actually processes the data coming up over serial. Upon reception of every data, you can see the timer gets enabled. Now let's have the testing with qModbus. So I have this Arduino Mega with me. It is not connected, as you can see in the device manager. It is not showing the COM port here. So let's connect it. Now I connected it. So it is COM8 it is showing. So we'll switch to the qModbus. We have to select COM8. Baud rate is 9600, data bits 8, stop bits 1, and parity none. make it sure it is happening. Slave ID I have set as 1. As I said, it can be 1 to 247, which you can set uh, in the Modbus RTU file. Here it is in this place. So let's read the coils. I will not start from 0. Let's start from 24 to let's read 8 coils. So the default value I have set is FF, so that is it is showing FF. Here is the value. There is a standard response from the controller coming up on the qModbus. So in the document that I have shared in the blog of the qModbus, you will get to know more about it. Then read discrete input. Let's go again from 24 to 8 coils. Again FF I have set. Holding registers. Holding registers are of 2 bytes, so let's check only 2 registers. So as you can see, there is FF, there is 1, 24, number 24, and this is number 25. Input registers. I have set the value of input register as AA55. I can show you in the code where I have set it. It would be get more deeper understanding. Here you can see in the initialize EEPROM function, I have set it as 0AA55. In the Coils function as a specific idea of communicating. For example, you are reading from address 0 to 8. It will give you the value SS, which is quite correct for us. But if you try to read something like, let's say, 4 coils from the starting from address 0, then it will give you F0. Why this is happening? Because it is padding the rest of the values as 0. It is not going to read those values. So keep that in mind when you are reading the coils. To make it understand better, let's start from address 4 to address 8. It will give you FF. But if you read starting from address 4 and only 4 coils, it will again give you F0. The same is true while reading discrete inputs. Writing the single coils works like, for example, I want to have the address 0 to be written as 0. And it will come as, this is a response. And when I read that coil, let's say 8 bits, as you can see, the 7F comes, not the SF, which is at the first place. It was a first place reading, and this is the latest. So the first bit got 0. Next function is write single register. So let's write the 32nd address with the value, let's say 250p, and send it. So now let's check what is the value on address 32, but of course it's going to be 1. So FD, next comes the write multiple coils. As we wrote the 0th address as 0, let's write another 2 addresses starting from 1 as 0. So now if we read the 8 coils starting from address 0, The response is F8 that makes 8 means in binary it's 1000 that makes 3 byte 3 bit 0. Then the last function is write multiple registers. So again let's write from 33 because we have written 32. So we will write two addresses. We will write one with 254 and one with let's say 252. And if you use them, so it makes the completion of 8 functions subset that is executed with the Modbus RTU slave acting in a microcontroller. We have two error conditions being reflected in qModbus while using this. As you can see, the maximum number of coils is 64. Registers are also 64. I mean, we have set the values as 64. So if we try to go beyond that, those values, we'll get some errors. For example, let's say I try to read the C4 address with a read call function, let's say. So the maximum value it can take is 63, not 54. So it will throw an error like this. This is the first kind of error that can be generated. The other one is the summation error. For example, I want to read uh, from start address 55 and I want to read 10 bits or 10 coils starting from that. It will make 65. Again, it will throw error. But if I write 9 here, it will give the value. Now, let's check the functionality of EEPROM, whether it works on the power cycle or not. So, I'll now disconnect this Mega and going to reconnect it. And open qModbus again. So first thing I will notice now is reading the coins. As you can see, the value restored. It is not asset anymore, it is the previous value written. Again, if we read holding registers starting from address 32, get FEFEF works quite well here. The EEPROM of Arduino Mega is 4096 bytes. That is why I preferred it. You can use Arduino Uno. The only difference that makes Uno working is only one line of code thing that you can make somewhere here. Mega is having multiple user channels, so I have used the zero channel here. But Uno has a single channel, that's why you can use this ISR definition. As I am using 64 coils and imports and registers in my library, uh, the Arduino Uno EEPROM is not making any issues. It is quite under limit for that part. If you increase this if you increase this number, then the limitations of Arduino comes into picture. Otherwise, this is quite okay. Every function works quite well in that. All right, so we want this library to get tested more by putting it open source and sharing it with fellow developers. We are finding a bug right now in some right multiple coils when I was presenting this, but I'm sure I will be figuring it out. But till then, anyone can tip into this and try to solve the issue. The report the issues to me as well. I'm available at kilomath@tempus.com email ID. I also written a blog on this, the link of which is shared in the description of this YouTube video. So please feel free to read the blog, test it out, test more, and let me know your feedback, queries, comments. Criticism is always welcome by me. Thank you so much. Oh my god, I'm back with Arduino Mega and the bug fix. Let me quickly connect Arduino Mega. Let's open qModbus. So as I mentioned, I was facing some issue with the right multiple point function. This tool, qModbus, is having some tenderness issues, I guess. I had to change the library accordingly. Still, it is not completely done yet due to the limitation of this tool. So let me get into this. Let's have the start address as 9. Then let's write 5 coils. So I write one here, and one here. Then standing. So when I read these coils, the same starting and the same number of coils, I will get something like this, which is not desirable output, right? But if I change something like this, starting address 8, number of coils 8, I mean both are in multiples of 8, and that consists the number of coils and the starting address required. I get something like this. Now you can see we set the values, whatever we set, we are getting them here. So this was a small fix that I got. So just a quick advice, whenever you want to write multiple coils, you can write from starting address anything and number of coils anything. But whenever you are reading them, always try to use the multiples of the syntax, start address, and number of coils so that you can get the desired result. I consider this project very important for the industry, specifically plant automation side, because if you see the number of coils that can be turned into controlling the actuators and the number of registers that can be used for the data transmission and reception. So it can be used very cheaply in industries. I am very much enthusiastic about sharing this project as open source. It is rightly said, when you explain your work to someone, you get a deeper insight. So while presenting this project on this video, I got this work which got me insight that I have to fix it. The library can be used commercially by anyone if required. So thank you so much for patiently listening to this video. See you again next. Bye.